Shalom from Israel, Guten Tag, as we saw, Shalom. Our name is L7 Defense. We're a relative young startup, and we recently got an investment for Trump. You can see there below, I'm probably mispronouncing it. It's a very respectable German company. So in the last couple of days, you had most of the presentations here in German, and but my German is very poor. Maybe now with Trump, I must work on my German. And this is, by the way, this the second time that we are getting an award from Frost & Sullivan for product leadership and innovation. And maybe today, when I start my presentation, I want to share with you that 2 weeks ago, I got my second flu shot, and we're already seeing a huge impact in Israel with this COVID-19 shots. It is amazing what modern science is doing, and L7 Defense, funny enough, is really based on the immune model as well. And we're going to share about it. I'm going to share a few words about it. Okay. So my objective today. Yes. Did I do something?
There's no presentation on my screen.
Oh,
so
okay.
Maybe have a look. Back again. Thank you.
Okay. Okay. I'm not going to touch anything now. Okay. So my objective today is really to provide you some insights about API protection. Let me go to the next slide. Here you are. So many people do not really realize how important is API and what is API. Just a few slides to share with you what is the importance of API. You can see Salesforce, the largest CRM company in the world, today is producing 50% of their revenue from APIs. Expedia produce 90% of their revenue from APIs, and eBay is producing roughly 60% of APIs, and it's growing very rapidly. In a typical organization, you will see hundreds of API. In some of them, you see thousands. So what is really an API? So I use a wide definition that an API is really the way that you operate in a request-reply mode. So if you have any servers or technology or computers that are getting reply and request mode, it's really done through some sort of an API. And we see three types of APIs. The first one is the public or the open APIs, and they are used by partners and developers basically to communicate back and forth between organizations and the public. A good example: think about your credit card. You're connected, or your banks. You connect to your bank through your mobile application or through your computer, and you check your bank account or you check your credit card status. That's done through an API from your device to the bank, and that's why you're using it. So it's very important that this API will be secure and not be open for cyber security attacks. The second type of an API is a partner API, what we call a business to business, and it includes suppliers. So let's say that you are an organization and you have many suppliers, and they're connecting directly to your system, to like your ERP system, in order to share inventory or maybe to share trouble ticketing and etc. That will be the partner. And the third one is internal type API, which are used by developers and within enterprises, where in order to communicate between applications that sits within the organization as well. So that's really a high level of the APIs. And maybe let's start speaking about some threats and the recent breach in this environment. Starting with SolarWinds. This is a very technical slide or a busy slide, and I just want to share with you about the SolarWinds. This was one of the biggest and most dangerous or deadliest cyber attack that was discovered. And maybe let's switch a more of a business more like slide and I explain what you see here. The gist of what you see on this slide is the attack was actually generated to an API. someone was able to hack into this software called SolarWinds, and through this API, they were able to attack many customers that was using SolarWinds. So overall, SolarWinds is a highly sophisticated supply chain attack. It means that it's coming to a partner, to one of your vendors that is providing you services, and it's attributed to the Russian government. So this is one of the first time that people claims that the Russian government are standing behind a very large-scale attack. Very serious acquisition. It's almost a declaration of war by the Russian, and I think they're taking advantage of the change in regime in the US. So the hackers actually exploited a software update for remote access on this application, and it was blended into the network activity. So imagine what we see here, that these attackers was able to sit in key government, key consulting, technology, and telecoms for over 7 months. So we realize now in the cybersecurity community that this so-called, they think it's the Russian government, was inside the American or the US government and many thousands of other organizations, including Microsoft, for months, for 7 or more months, actually sipping to technology information, taking information out, and nobody really knew about it. So that can be a very, very severe situation. Many companies, some of the biggest and the most sophisticated companies in the world, had this false pretense, false feeling that they were secure, but in reality, they were unsecured. And I will go back to this point in just a second. So another big trend that we see is this API attacks that I mentioned are getting very sophisticated. Today, the hackers are using artificial intelligence, what we call a machine-based attacks. And this is, you can see some of the terminology, whether I'm not sure how many people on the call today are deep into cybersecurity, but this is some of the terms you might hear, like cache poisoning, zero-day exploit, which means it's an exploit that never seen before, first time ever, like SolarWinds. We haven't seen such an attack to this tool ever. Denial of service that's been around, but it's becoming more and more severe. Binary planting, content spoofing, brute force attack, which becoming very common using very strong computers. I'll give you an example. Think about your password. Many organizations tell you use 8-character passwords, use one upper level case, and use some sort of a special character. So you go into, if I'm a hacker, I go into my computer, I set my algorithm to 8 characters because many people just go with for the minimum security. And I will say that the first word will be uppercase. And then I'm going to start using a brute force, a very strong computer, in order to try to penetrate the account again and again and again until I'm able to brute force and to gain access to the account. That's an example of a machine using sophisticated tools. By the way, a lot of these tools today can be purchased over the internet and can be used to penetrate their organization. So there is the traditional protection. So there is some of these tools you might have heard, and every organization we visit today have cybersecurity in place. The issue is that some of these systems are old and not very effective. However, you know, if you look inside your organization, no one is brave enough to touch them or to challenge the legacy security. And I think that you need to ask yourself, and maybe that's one of my message for you today, guys, are you open to challenge your cybersecurity systems and actually benchmark? Let's say that you have some of these applications. Are you open to look at, innovation, innovative companies like us, and tell us, hey, I want you to benchmark against of my legacy system, and to see, compare, and to see if systems that was developed, you know, some of them 30 years ago or 20 years ago are still very effective. I think that overall what we see is the cyber security field is moving very rapidly. It's a huge market. The cybersecurity market today is over $100 billion in revenue and growing very rapidly. And one of the reasons, because there's a lot of money, especially for the hackers. You see very successful groups that are able to get a lot of money to Bitcoins, and no one is able to catch them. So as a result, it's encouraged more people to become bad guys and to use this technology in order to tackle organizations. So the main issue in what some of the system I mentioned here, and that really will cover the market issue, is a very low rate of discovery, especially now with the very sophisticated type of attacks that knows how to hide themselves, so they will not be detected by normal or the regular security measures. The precision, it's also a big concern. What we see in many organizations, you have security system in place, and they generate a lot of false alerts. These false alerts have to go to a team of experts that looks something we call a security operations center or SOC. They will analyze the potential threats, and they need to come back with an answer: is this really a threat or not? And it takes time, and it's becoming more expensive. You need more people in order to really analyze the amount of security threats. And the last one is automation. I will share a few customer stories in just a few slides, and you will see that in many of the organizations, there's still analysts, a lot of analysts that are sitting there going through tremendous amount of alerts, trying to analyze and trying to find out if it's real or not, and really what action that needs to taking against it. And it's not very scalable, because if there's more and more machines that are attacking you, you cannot react to machine by human. You need to start putting machine and smart machines in order to tackle it. So let's switch and let's discuss what we do in L7 and why we believe that we are so innovative. Starting with immune, the immune, I mean, we actually, the name of our product is Immune in A, and we name it after the immune system of the body. By the way, we started the company a few years ago. The founder and the chief technologist behind the company is actually someone that specialized in bioinformatica, and he really liked the concept of the immune system, so he tried to mimic the innate immune model in the way that our system works. And give you a few examples. If you think about the immune system and the innate immune model that we have in our bodies, one of them, it works automatically. You know, when you get sick, nobody tells the body, hey, you might sick. You don't need to measure temperature. The body knows automatically. You measure the temperature all the time. He knows that you're sick, and he gets into an action automatically. He does not ask for permission. He just starts working and start detecting and start working against the threat. The second thing is, if you think about our body, the way that the immune system works, it's highly controlled and it's very precise. So, for example, you get injured in your let's say shoulder, the body is going to handle only the shoulder. It's not going to start sending you're not going to see inflammation, or you're not going to see other reaction in your leg. It will probably be very precise and very controlled in this specific area. It's also autonomous. You know, there is no intervention. Everything is automatic, and it's also very straightforward. You don't need to do almost anything. Everything's working. And what you see here, we took the same concept and we says, can we build a system that will follow all of these things? And we also will have a system that teach himself. What we're doing now with the COVID-19 injection, right? You're getting the injection, the body develop the immune system in order to know how to work against the COVID-19, right? And then you get the second shot that is actually ingraining this protection mechanism into the long-term memory of the body, into the immune system, and now you're protected against the COVID-19. So the same concept is here. You have a very sophisticated artificial intelligent machine learning, a system that learns all the time how to become smarter and smarter against these attacks. So what we see here on this slide is our secret is really assigning a lot of artificial intelligence machines. Just think about a lot of artificial intelligence machines, each one for every API. And each of these artificial intelligence machine or instance is looking at this API from different directions in order to analyze it for example, for change in behavior, for change in patterns. And we take, for each API, we take decisions based on several factors, and that's making it very intelligent. So you can see here, starting with the discovery, you discover the APIs. In many organizations, there are thousands, as I mentioned, thousands of APIs. Sometimes people develop APIs and maybe the programmers change an API and the security team is not actually aware of the changes that was made to the API. So phase number one is to discover, to understand what is the APIs that you have in the organization with your partners, with the public and internal APIs. This process is a very important process. After you discover the APIs, you go and you start building adaptive policies. You start learning the APIs, understanding how they behave, what is legit and what is not legit. And then you go to the API protection and you start realizing there might be content attacks, context or business logic attacks, bot-driven attacks, and denial of service type of attacks. And you go and you discover it again, and you do it all the time. And this process takes seconds. And you do it around thousands. Just imagine thousands of this cybersecurity artificial intelligence tool working around thousands of APIs. For each API, several AI machines working at the same time. Very, very sophisticated, very fast. Keep protection, protecting, unprotecting, protecting again, and adapting to these changes. I know it sounds very complex, but it works fantastically. So the results we can see here is three different elements. The first element is that you have a fully autonomous, highly accurate API security solution that knows how to discover the three parts that I mentioned: the public, the third party, and internal. He knows how to detect both the AI-made type APIs and including specific tailor-made generation. And the last one is defending, and this is an online definition, which means you see an attack, you don't send it to a human to evaluate. The machine decided on the spot how I'm going to react to this threat. Am I going to let it pass, or I'm going to block it immediately? So the reaction is immediate and very effective from this perspective. Next one, most of the activity is done automatically. So you don't need to define any rules. You don't need to operate the system. You just install the system works and start behaving in all the cycles that I mentioned, analyzing, defining, and detecting us. And typically what we see is that you need no more than 2 hours of training in order to learn the system and learn how to read the reports and really understand what's going behind it. So let's go over a few use cases. Use cases number one, and since this is hosted by Vodafone, so I'm giving specific examples from large communication service providers that we're serving today. So use case number one, this is one of the largest communication service providers in the world. So that's the first one. So we had, like, after 2 hours of installation, the artificial intelligence was gathering the API schema. By the way, just to compare in all the system, it can take 1 to 2 weeks. In this case, they were very skeptical because they said, hey, we have an amazing security systems in place. So if you can, I would like to connect you after the legacy security systems and they were shocked to see what we're able to find, because things were leaking, going through their system. For example, over 1 million credential staffing attacks on the first month, over 100 accounts takeover that was stopped by our systems. We were able to stop a lot of vulnerability scanning by attackers. Many times, attackers, before they make an attack, they start scanning the system. They're trying to find vulnerabilities. They're trying to find holes, and we're able to stop these counters. And we're able to stop some brute force attacks. The second use case, and this is very, very interesting because it's a very difficult case to find by any security system. And this is something called a business logic type of attack. And I give you an example. So here we are. This is a large telecom, and they have a call center reps, that they provide customer support to their customer. And in this case, we saw a very suspicious type of activity that was coming from within the network of the operator. So it was like an inside job. And we asked ourselves, how come we have here, do we have a dirty employee, someone that is acting on behalf within the organization? And what we realized that this was actually a customer service representative that was trying to be very kind to the customers, was trying to be very useful. So when the customer told him, listen, I've got issues with my system, he told him, give me your username and password. I will log in on your behalf and I will make the changes in your account. This was against, of course, the telco policy. The telco, because of the GDPR, do not want that the employees will know the passwords of the customers. And we were able to find it. Just imagine how difficult it is to find it by any security system. So we were able to find it, and actually we notified the management, and they had a lot of training and correction to the CSR to make sure that people understand why and what is the risk for the organization. The third use case, we are protecting a government MSSP. And so just imagine that government has portals where the citizens can go into the portal and you can do different things. In some places, you can vote through the government portal. Sometimes you can go and change your ID, or you apply for a passport. That's the type of things that you do from the government portal. And in this specific case, we know that government portals are under severe API type attacks by both humans and by machines. And so we deployed our inline immune API security system, and we start finding different things. For example, find scrapers. What is scrapers? Scraper is some sort of a program that goes to, let's say, a government site. They try to fish ID. For example, they ask for your social security number in the US, or they're saying, they're putting query, they're getting information back, and then they put another query, and suddenly they build a database of citizens, a database of information by doing this query back and forth using automatic rules. That's really called the scrapers. And we are able to block these scrapers despite the fact that it was coming from different IP addresses and trying to do a very sophisticated type of scraping activity. Credential staffing, where people trying to steal identity, trying to steal credit card or payment information. Denial of service, where people are really attacking the government portal, trying to collapse the portal. And the nice thing is we're operating completely in autonomous mode for several years now. Use case number 4. Again, this time it's from a large national bank. I don't know if you know, but the banks are requiring now, there's a new legislation started from the UK called the open banking, where banks needs to open the networks, and the banks are under constant attacks because they need to open their APIs to other financial institutes. They cannot supervise the other banks or the other institute security. All they can do is verify that, let's say, I'm Deutsche Bank and I'm receiving a legitimate connection from a different bank, so I cannot block it, but I cannot check the other bank security. So if the bank was breached, is actually can allow the attackers to go to this API. And here, that's where we play. We got very deep into this traffic, trying to see what is going there, and we're able to defend this bank. The last story that I have, this is from we just finished a trial with very large European communication service provider that we're all familiar with. So they compare us to their legacy security system, and we were 700% better. Guys, look at the number, 700% better. So the telco, I think, understand that it is a major issue, and we hope to hear from them shortly. And I think that you know, it's never easy to admit that you have a problem. And to my last slide, Doris, and so we are L7 Defense. I believe that we've been recognized as quite an amazing technology. We're looking for customers. Please test us, and we can demonstrate the value. I really appreciate the time that you gave us today, and I'm very glad to be part of this very innovative technology forum.
Thank you